Hi, this is part 5 of the sampler Loopstation project. If you'll recall, last time we just set up a interface for it, and we have a cursor that's being driven by Super Collider, and we have the ability now to record and to play. So let's just get that setup going. This is the code I left off with last time. So from part 4, so I'll go ahead and boot my server, and I'll start up my preliminary, sending the variables and the synth defs and all to the server, get all that stored up and ready to go. And then I will, I guess, kick off. Well, I don't really have anything to do there except to start the indexer, right? So let me start the index there. Right, so that synth right there is going to start our index. And remember, it's an on-demand thing, so processing has to send a message here, get index, to grab it and then to send it. And then I'll run my processing code. We go, we have one track and the cursor running based on information it's getting from Super Collider. So this time, I think what we'll do is we will now try to automate the functions of recording and playing from processing. So we can send messages from processing, from our GUI, from our interface, to Super Collider to get them to start recording and then start playing, and et cetera, et cetera. Okay, so actually, I don't know if these were here last time or not. So let's talk. The first step here is to talk through or code through how to do it within Super Collider. Okay, so let's start with record. So if we want to record, we're going to have to create a synth, and I'm going to change his name. I think I call it RecSynth. Okay, so if I'm going to create a global variable. I'll call it RecSynth. Okay, so if I create a recording synth, then I'm going to, of course, have the index going, and I'm going to send a synth, and I'm going to use the synth def buff record. Okay, so actually, let me just redo this based on this. We'll just retype it, so we can do it step by step. Equals, because I'm going to assign a synth to that variable RecSynth, a synth. Okay, and then remember, it's just going to be the scope like that. Now, the first argument it's looking for is the def name, or the synth def name. And remember, we use that symbol format, the / and we're going to use the synth def we call the buff rec, right? That's the one we wrote a couple tutorials ago. So let's do that, buff rec. Okay, and then the comma for the next argument. So these are the arguments that are the initial arguments. So those are when we start the synth. If we want to change, we want to start it with certain arguments changed, we'll do that. Now, I do want to update you on one thing, actually. So let's have a non sequitur a little bit, pause there. In my previous tutorials, I had decided that I was going to try a different strategy, and that is to use a gate, and I said a done action. That what I was going to do was I was going to create a synth on the fly with my OSC def, which you'll see later, and then I was going to just kill it with a gate 0, and then a done action 2 was just going to wipe that synth away. It was going to take it away. Now, I have run into some complications with that. I think it's definitely doable. It's just probably a little bit too complicated for just this one bit in the scope of this tutorial. It's not too complicated, but I just think it would complicate things in a way that's probably not useful right now. So we'll just go back to the old way. So basically, the idea is that we'll have at least one, in this case one, but if we have multiple tracks, several synths that are running as recording. So the recording, and then at a certain point, we'll just turn the envelope on so something's coming in, and turn it off so something's going out. Okay, so hopefully that makes sense to you, but you'll see. So I just have to alert you to some changes if you're following along through the tutorials. So we're going to start that as a gate 0. All right. So that just simply means that the envelope is 0, multiplying the in, which is our mic signal. So that means if there's no gate, it hasn't started yet. So it's just 0 all the time. Even though it's really writing to the buffer still, it's writing zeros to the buffer, so there's no sound. Okay? And we're just going to get rid of this done action too, because the default done action is 0, which is do nothing. All right? So those are two things we have to change. I thought to change that on the play. Though the play I think we can keep. I think we can keep the play. Let me see what I did. Sorry. Let me see how I updated it. I did buff play. Yeah, I kept the gate. That's right. Okay, I kept the play going, but I changed the record. Oh, no, I kept the record. Yeah. What did I do? Okay. I changed the play, but I kept the record. Why is that? Okay, I see I did a hybrid with my actual code, but I think I'm going to change that. I think I am just going to go back to the original thing. So we will get rid of both of those gate ones, 0. We're going to get rid of this done action as well. Okay. Right. So those are just two changes there. Get rid of that done action, change the gate back to 0. All right. So then when we create a record synth, then we have to set it with these initial conditions that are arguments. And the way we do that when we instantiate or initialize a synth is we put them in an array, or these brackets, square brackets, right? Okay. And then it's pairs of argument name and argument value. Okay. So the argument name is buff, because we want to assign a buffer to record into. If you recall, we'll just do a quick review. We created a buffer, a sound buffer that will hold our sounds. Okay, and it's going to be the total number of seconds in our track, which is just a 4-measure 16-beat track at 60 beats a minute. So that's 16 seconds that it'll put in there. And so then we're going to have to refer to that buffer. Now remember that buffer's name is called sound buffer. So this argument is telling our synth-def which buffer to record into. So it's the one we named SNDBUF, right? Okay, so pairs of argument names and values. So even though there's a variable, it's still saying, record to this buffer sound buff. Okay, and then our next one will be the index bus, because it needs an index to help it run through. It's just this structure of my own devising, that instead of having a internal object within the synth-def, we're reading from an external object, so we can sync. Everyone can sync to this external thing. Normally, we just put a phaser in here, into this index here, and it would just, it would have this time-dependent signal change over time, saying, okay, let's drop into sample 1, drop into sample 2, drop into sample 3, drop into sample 4 over time. All right, but this time it's an external thing. So we do need to tell which bus we're reading that. So we're reading from a control bus, or an audio bus, actually. So, and we call that argument IDX bus. Okay, so I'm kind of going over these things fast, but these are things we've covered in previous tutorials. If you find this part confusing, or any part confusing, I guess I would recommend going back over those old videos and seeing, what that might help clear up things up. And once again, let's just quickly look at where it's coming in from. We created an index bus, IXA bus, or audio bus, and we made a private audio bus. So that's, it's kind of like a patch bay. It's just going nowhere. It's sending audio to an empty bay that we then later can patch into something else. So we have an index bus, and that's being patched into, we're going to do the IXA bus. Okay. And then finally, so we're going to start this synth. We're going to start the synth with the gate closed, okay? Because it's going to be running from the beginning, okay? So when we initialize all our code, and I'm going to change the name of that to something, let's see, IXSynth. And then I'm just going to put, let me make that slightly smaller so it all fits on one line. And I'm just going to put this into like another two, these brackets for another set for execution. So then basically when we start, we're going to execute all these things first up here, send all the synth defs and OSC defs, and then we'll send these, which will start synths. So they'll be running on the server, but in fact, they won't be used yet until we give some other signals, okay? So if you can follow along, the index synth will be running. It'll just be running along, ticking away, ticking a number between 0 and 1 continuously. And that's also where we get that cursor information. And then this synth will be going, except since gate by default is 0 on the envelope, it will be multiplying by 0. So there'll be no signal going into that buffer, okay? Even though it's writing to the buffer, it's not. It's writing zeros, okay? So we're not going to change that just yet. We won't actually start it with a gate 1 yet. Once we hit gate 1, it engages the envelope, turns it on, and then it's actually writing whatever is coming into the mic. Now, the last thing we do, if we just look up here, this thing, is we have to assign this to a group. So we're starting a synth, but we're starting it with special conditions. Are that we're starting it on a specific group. And what do I mean by that? We went over it, and that's to say, kind of separate in our heads. There is an audio stream, I guess, and we kind of think of it metaphorically a lot like we think of mixers and patch bays. We're sending audio signals. But there also is the data, or the programming, the computer calculation stream. And we have these groups now that are going to take the place, kind of placeholders for order of execution. So we have an index group because we need our index to go first, to be calculated first. We have our in groups, which is everything that's coming in, and then we have an out group. That's everything. After out group, after IX group. Okay, the out group is the last thing, so it's everything going out. Okay, so we have to record before we go out, but we have to do it after the IX bus. So I mean the IX group. So we'll have this. I think it's IGR. Is it INGR or IGR? INGR, okay. INGR. All right. So that's going to be added to the program stream, the order of execution stream in group, so that we can calculate the index first, calculate the ins, whatever's being recorded, and then for the playback, we can calculate the out. Okay. Hopefully that makes some sense. All right. So there we go. We have this. We're going to have this running then. And then what actually needs to happen? So let's actually do it in real time. So I don't think we'll be hearing the results because we don't have the play synth, but you can just sort of I'll just talk us through it. Okay, well, let me recompile real quick. And then I'll boot. Send all this stuff. I can click anywhere between those two parentheses. So I'll send all the variables and the OSC defs and everything like that. Okay. And then I will send these to synth. So it will start the index synth, and it will start this record synth, but remember, again, envelope will be 0. Okay. So we actually have to do two things to do a proper recording. Or no, actually we have to do one thing to start a proper recording, but we have to do another thing to stop it. Okay. So the one thing we have to do, and again, let me just back up one step and to simply say, what I'm showing you right now is how to do it just within SuperCollider, as if you're not using anything else. And then basically we're going to create a way to remote control it from the outside world, namely processing. But basically it's still going to do the same steps within SuperCollider. We're just going to add those steps to these OSC defs so that we can control those steps from the outside. But first we have to have an understanding of the steps it takes within SuperCollider to actually get these things working. All right. So step 1 for recording is to start a record synth based on our buff record to give it all that's necessary information. All right, so it's going, except the one exception is that so we can do things kind of on the fly. We can turn it on and off. We're going to take the rec synth and we're going to set the gate to 1. Okay, so that just sets that envelope gate to 1, and it ramps the envelope up. So now our in signal is no longer being multiplied by 0, which is the envelope signal. Instead, it's being multiplied by eventually 1, hopefully. So then that in signal is now being written to the buffer. Okay. If the envelope is 0, it's 0 being written to the buffer, right? And the initial conditions with gate at 0, if we don't change the gate with a gate default at 0, then the initial conditions will be a 0 signal coming in. It's still being written to the buffer, but it's coming in as 0. Okay, so if we set the gate to 1, again, you'll just have to take my word for it because we don't have a playback set up. So if we set the synth initially, like if we initialize our code and this is going, it's running, it will start recording then once we set the gate to 1. So if I do that, now presumably I'm recording, right? And then I'll record and record. So this is for the looper sampler. So I record a little sample that I want to loop or want to play back at a later date. And then dot set, if I want to turn off record, I just set the gate to 0, right? So once I set the gate to 0, my input signal is being multiplied by 0, and nothing's being, well, zeros are being written to the buffer. All right. Now this is very important because the zeros are being written to the buffer. So in fact, once the index here gets around to where I've recorded, then it's going to override it with 0. So that's the next step that we have to think about. So this kind of works because we're recording with envelope 1, and then we're stopping recording with envelope 0 because nothing's being written. But in fact, that's not true because this index is running through. It's still going through the whole track. But in this case, instead of writing what's on my mic through, it's writing 0. So it's just going to delete what I recorded. So we won't ever hear anything because by the time it gets around, it will be zeros again. Okay. So another thing we really have to do then is we have to stop the index from moving. Okay, right? Does that kind of make sense? So when we record to a certain point, and then once we stop recording, we don't want it to move. We don't want it to write stuff anymore. Okay, I hope that kind of makes sense. Let's see if I can bring it to a little bit more clear. So in the recording, this index thing, this argument here where it says phase actually in the supercollider speak, that just means basically it's, so if we think about, let's see if I can have a metaphor here. If we think about a flip book, you know, those flip animations where you draw somebody, whatever, doing jumping jacks or something like that, and each page is, you know, with the legs and the arms slightly more up in the air and slightly less up in the air. And then if you flip through, it looks animated. It looks like they're doing jumping jacks, right? So the phase or this index bit is that it's the flipping through. If we flip through it a little bit slower, it looks like he's doing jumping jacks slower. If we stop flipping through, the animation stops altogether, right? Okay. If we skip around, then it looks like kind of random, like he's randomly flapping his arms or doing that kind of thing, right? So that's what that index controls, is the flip. It's the flip part of it. So when we're writing, if that flip part is going, and we're writing into the bus, if it's still going and it's writing zeros in the bus, it's just going to erase all our animation. You know, it's going to erase everything on each page. So what we have to do is, in addition to putting the gate down to 0 so nothing's coming in, we also have to stop the index, okay? And what is this index coming from? What's coming from this bus, a sound in, which is not sound actually, it's just an audio signal, which is our indexer, which is giving us it's this phaser. It's giving us our signal from 0 to 1, which is counting through, okay? It's the flip part of it, okay? Hopefully that's a little bit clear. So what we need to do is we need to stop that. So one way potentially of doing that is simply to create a buffer signal that's a zero-sum signal, okay? So let's see if I implement it here, just so I implement it similar. I think I did change some things, but hopefully I still have something similar. IX buses, IXK buses, tracks, RTOX, IX bus, RTOX. Okay, I might have gotten rid of it. Huh. Couple ways of dealing with this. One way is to then, we're going to set the gate to 0, so that means nothing's coming in, but it's still writing zeros. So what we'll do is we can either set the index to not move, and that's a little bit trickier than it seems it should be. Also set it instead to a sort of a dummy buffer. So now it's writing this information into a different place that we're not going to be reading from, not our actual sound buff. Okay, so that might be something to do. So when we want to turn record off, record on is easy. We'll set this, but we actually might need to set our buffer back. So we're going to have to do that. And then to record off, we're going to turn the envelope off and then set the buffer to a different buffer. So it's no longer writing into our proper buffer, the one that we're going to be playing back from, but in fact it's just writing to like a placeholder buffer. Okay, so we need to create that buffer. Let's just do it under the sound buffer right here. I'm going to create a, I'm going to call it maybe 0 buff with a Z. Okay, and then I'm going to make a buffer. So I'll just copy the same language there, buffer dot allocate, LLOC, and the server is going to be S, and the number of frames is going to be the same. Let me get out of there. Same as this, the S dot sample rate. That's the sample rate of the server. And then it's going to be, which is if you have one of those, a sample rate, which in this case is 44,100. So s.sampleRate is a number, which is 44,100. So if you have 44,100, that represents 1 second of frames, or 1 second of samples. And then you just have to times that by the number of samples. So that's what this T6 is. And that's the seconds for the track, number of seconds in a track. Okay. All right. So we're going to get a 0 buffer, make the buff. And we're going to create one there. Okay, we'll call it 0 buff. We remember that name. And so our second part now will be to move that recsynth.set. We're going to, oh, actually we can do it all at once then. We'll just do it in the same command, which might be a little bit simpler. So we will set that to buff and then to 0 buff. Okay, does that seem to be clear why we're doing this? It's fine and all dandy to set the envelope to 0. That means nothing's coming in. Our mic signal is being multiplied by an envelope of 0, so no signal is being written. However, since our index is still running through the buffer, we're writing zeros to a buffer, so it's going to erase anything we've already recorded. Okay, we'll record. So instead of doing that, one thing is to just kind of like a train switcher. We're going to switch the buffer to a different buffer. So then now we're writing zeros somewhere else. And whatever we recorded initially is being preserved because we're writing to a different, it's like being on a different train track. We're writing to a different buffer. Okay. So in this case, when we start though, so it's fine the first time because we set our buffer here to record into our actual sound buffer. But the second time we do it, so if we stop and then we want to record again, it's still writing to the 0 buffer. So this command actually needs to be not only set gate to 1, but also set the buffer back to its sound buffer. So let's add that there. Okay, so we're going to set 1. This is to start recording. Then this one here is to stop recording. Okay, those are the 2 commands we need to do. So this is initialize. This is the initial state. Start. So this is, will be done at the very beginning when we start our code. But this happens later on the fly, right? So we want to do these 2 things. We want to be able to start recording and then stop recording. Okay. So let's then set that up now. So the next step now is to set up a message that will actually do these things. All right. So we'll use our OSC def. And then we can remote control it. So within SuperCladder, we can just, command return and it'll set it and then it'll stop it. But if we want to remote control it, say from processing, we have to have it an OSC def or listener that's going to listen for a certain message and then execute a certain command, right? Which is one of these. So that's why it's just sort of important to work out what command we want actually to execute before we start the OSC def. So OSC def, and remember the syntax is basically, it's the scope. First command is just the internal name, which is, we just got to make sure it's unique. So this is recon, we'll say. Okay. And then it's a function, which is whatever we want to execute once we get a certain message, a certain OSC address or name. And then the third one, in fact, is the OSC name. Space then, remember, it always has that /, and we'll just use the same name, recon, and then just the end quotes there. Okay, so that's what's happening. And then we'll just give ourselves a few lines there to work on. So when it receives this recon, we basically wanted to just execute this start recording, right? So we aren't sending any messages, not yet. Okay, we will, because this is just one track. And remember, we'll expand it to multiple tracks later, which does kind of complicate our code, but if we step through it, it won't be too bad. All right. So then, so if we create a line here and we just simply say that once it receives this recon message, then it's going to execute this set. So it's going to go rec synth.set, and it's going to set the gate to 1. So it's letting the mic in, and then it's going to set the buffer to the sound buff. Okay. So then it's actually writing to the sound buff. Okay, so that's pretty simple. That's easy enough. So this is once we execute our initial code, it's ready. It's listening for recon. As soon as it hears recon come through the pipes, it's going to do that. It's going to set on the start recording thing. Okay, and so for rec off, it's simply the same thing. It's always worthwhile to retype things, so I'll recommend that for you. I'm copying and pasting for, just so I'm not sitting here for so long and boring you. But yeah, rec off. Sometimes the problems with copying and pasting this is you forget to change some of the names. So both this needs to change, because if this is named the same as this, it'll just replace that OSC def. And here as well, our address has to be update. And then we're still resetting the rec synth, except we're setting the gate to 0. And the sound buff, and we're setting to 0 buffer, right, instead of to the sound buff. So it's now writing zeros into a different buffer. Okay, so like switching tracks again. So now we have our two defs, rec on and rec off. All right. So what I'm going to do, just so we can test this, is I'm going to just create, I can get rid of these now. So that's, we've demonstrated that. We don't really need that necessarily. We might need it later if it doesn't work. But I'm going to get rid of these for now because we just want to remote control this. We don't want to do this within SuperCollider, really. But I am going to leave the C-Synth play because we'll have a playback running as well. And we'll get rid of these as well, too. So a playback running as well, so we can test, see if it's actually working. Okay, so here goes nothing. I'm going to recompile the server. And then I'm going to boot. And then I'm going to send all the OSC defs, et cetera, et cetera. And then I'm going to set the initial synths. Okay, and I'm also going to set the play synth, so it's going to be playback, whatever. I guess I could test it just within SuperCollider, but let's not do that. No, actually, let's go ahead and do that. Well, I got rid of it now, didn't I? No, it's easy enough. I can just copy this and see what happens. I do that, and let's copy this so I can shut it off. Okay, and so I'm going to set that to gate 1, and so it should be recording as soon as I go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then shut it off, and we'll listen. It might be 16 seconds. Okay, that might have been 16 seconds. I'm not sure. So it could be that it's not working. Okay, so I'm getting input, and that is reading from the index bus. Okay, let me just look into that for a bit, and I'll come right back. Well, so all it was I just forgot when I started the see the playback synth. I just forgot to make gate. There it is.
4, 5,
Gate
6,
1.
7, 8, 9.
Because remember I had changed it here to gate 0 in the playback. So it was working. It just, the gate wasn't open for the playback, which is just a placeholder right now. It's just a sample playback. So that works. So I recorded.
1, 2, 3,
I
4,
turned
5,
off recording.
6, 7, 8, 9.
Okay,
10.
so let's stop everything now. Great. So that works. We've confirmed that working in Super Collider. Now what we need to do is to then get it hooked up in processing. Okay, so let's save that. Let's pop over to processing and see what we have to do. We have the OSC set up. That's great. So let's just make a simple trigger right now for mouse. Okay, but what I want to do then is I want to click once and start recording. Click anywhere on my my interface. And then I want to click anywhere on my interface again to stop recording. Okay. So we need a toggle, right? We need something that toggles on, and then you hit it again, it toggles off, and then you hit it again, it toggles on, right? Okay. So the way I like to build toggle switches is to simply use what's called a modulo. Now, I don't know how many times I reviewed this, but it seems like every time I do, I review it. So let's just go ahead and review modulo, just because it's a handy thing and to get it in. So it gives you essentially the remainder. Okay. So if I go to print line and I say, let's take the number 4. Okay. If I modulo 4, modulo 2, okay, that means that the number 4, oh, wait, let's do something better, modulo 3. Okay. That means, 3 goes into 4 once with a remainder of 1. Okay. So, so that should print out 1. Okay. So if I run that, it does. It gets 1 down at the bottom. You see there, 1. Okay. So if I go, 5, 4, 4, 4, 4, I have no idea. If I run that, oops, it's going to get 0 because I guess it goes into it fully. So 4, 5 will give 1, and 4, 6 will give 2. Okay, so just basically the number on this side is going to toggle through 0, 1, 2, 0, 1, 2, 0, 1, 2. Okay, so you can do the same thing with any number. You can toggle through 4 times. So 0, 1, 2, 3. So if I do 0, 1, 2, 3, it'll come up 0, 1, 2, 3. If I go say 5, it'll just reset. 5. Sorry. It becomes 1, and 6 becomes 2. Right, 6 becomes 2, etc. Okay, so you can have any number, and it's going to toggle 0, 1, 2, 3, 0, 1, 2, 3. So that's how you create a toggle. So it's handy because you can create any sort of toggle, not just as on off. Okay, but in our case, we just want to on off. Okay, so we'll create an integer up here, and we'll call it a rectog. Okay, and we'll assign it to 0 as its initial value. Okay, and then we're gonna we'll just do this step by step. Slow this down. Hopefully this is not too slow and boring for you. We'll toggle through. So we'll have a void with our mouse. Mouse pressed. And then we'll toggle through just so you can see. We'll say every time you press your mouse. So remember, void press, mouse press is that every time you press your mouse, it executes all the code within it. And we'll just update rectog. So we'll say rectog. Update that toggle, and we can use shorthand. We can say rectog ++ if you want. That just means rectog equals itself +1. So every time you press a mouse, it'll be it starts at 0, it'll be 1, and it'll be 2, it'll be 3. It'll just update. We can print it. 9. Okay, I can show you that. Okay, so if you look at the print, every time I touch it, should type 1, then 2, and then 3, and then 4. Every time I press the mouse, it updates the toggle and prints it out. Okay, so now what we want to do is we want to toggle it record on and record off, right? All right. So basically, we'll update the toggle after we run everything. Okay. So if it starts at 0, oh no, actually we'll update it first, because if it starts at 0, we press it, it becomes 1, and then it reads. All right. So what we want to do, well, we'll leave the print there for now. Maybe we won't want to print something later. I'll go ahead and use an if statement, and we'll say if rectog equals, and remember 2 equal signs for a Boolean, equals 1, right? Okay, then what happens? Something. And then otherwise, and we can do another if, or we can use else if. So that just means that if it's not 1, then it's going to have to meet another condition, which is fine. Else if rectog is equal to 0. I mean, we only have 0 or 1, but there might be a time later that we have more than one option. So else if it's equal to 0, then we'll have something else happen, right? And what do we want to have happen? Well, we actually want to have it to record and to not record, to stop recording. So we need a message, an OSC message, okay? And I don't know if you remember how to set those up, but you have to initialize a variable, an OSC message. So it's capital OSC, MESSAGE, and you give it some name, variable name. So we can say on, something like that, on equals, and then we have a new OSC message. And then the one argument it takes is the name, the namespace, the OSC address, which is rec on. And it has to harmonize with the one in our OSC def in SuperCollider. Rec on is rec on, right? Now, did I put the slash? I did. Okay, remember it's always / for the OSC messages. Now, we're not adding any arguments, right? Because we don't need data. We'll do that later. So all we need to do is just initialize that message and send it. So then we say OSC.send. Now, why OSC? If you recall, that's the name of our machine, our OSC sending machine. OSC, we initialized it as a OSCP5. It's the machine that does it. So we need our OSC sender. It's our postman. It's our post office to send that message. And what we're going to send, which is Ron, our OSC message, and where we're going to send it to, SC, which is our net address here. That's the address of the SuperCollider. All right. So OSC send, and then same thing here. And I'll just copy and paste. Like I said, it's okay to copy and paste. Well, you do what you want, but sometimes it's good to retype. Sometimes it's much more efficient to copy and paste, which is nice. But if you're learning, sometimes it's good to retype. So if you feel you have a really good, don't have a great handle on OSC message and the syntax and all, sometimes it's worthwhile to retype. Okay, so then we have, if it's 0, we want to turn it off. So rec off, and then we're going to send the message rec off, and again, harmonize with SuperCollider. We're still using OSC post office, postman. We're sending rec off, not rec on. And we're sending to SE still. Okay. So that is toggle. This will toggle it. So when we press it, it becomes 1. And if it's 1, yes, it'll send a message record on. And it'll ignore that. The next time we press it, it updates it. It becomes 0. Remember, because we're doing right. So we need a modulo. Okay. So actually, I forgot about this. So let's not use rectog ++ a shorthand. Let's use a longhand, because then we're going to modulo it. And that was that whole point of it. So we're going to say rectog equals itself +1. And that's exactly what that ++ does. Okay, it just does that. But what we want to do is we want to keep it either a 0 or 1, right? Even though it's updating every time. So we'll just put a parentheses around that. So first do that, just order of operations. And then we'll modulo it. We'll put a percentage sign, and it's 2. So it's going to go between 0 and 1, 0 and 1, those two values. Okay, so rectog will always, in this case, even though it's updated every time, will be 0 or 1. All right, because it'll get to, anyways, that's what happens. Okay, so, and then, there we go. We have rec on, rec off, rec on, rec off. So that means every time we press our sketch, it'll turn on recording. If we press it again, we'll turn off recording. So I'll save that now. I'm going to recompile there. You might not need to. I just forgot what state I left it in last. I'll boot that. I'll send the first bits, all that, to that parentheses down there. And then I'll send those synths there. And this is just a sample playback for now. We're going to create some buttons for playback. Okay, and then we'll start our oh, you can hear the little static because it's being played back my zeros, and we'll deal with that later. So I'm going to start this. That's running. So if I press record once, it should be recording, blah, 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 recording 1, 2, 3, 4, 5. And I'm going to record until I get to about the spot where I stop recording. Da, 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 la, la, la. Okay, well, I'll stop now.
Okay, so that's running.
Yeah, there you go.
So if I press record once, it should be recording, blah, 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 recording.
Okay,
1, 2,
so
3, 4, 5.
it seems to work.
And I'm going to record until I get to about
Well, let's do a little short excerpt. So I'll record 1, 2, 3, and stop.
Okay, well,
We'll wait till it gets
so
all the way
that's
back.
running.
Bear with me.
So if I
I
press
know it's hard waiting
record
as we watch.
once, it should be recording, blah, 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 recording 1, 2, 3, 4, 5. And I'm going to record until I get to about the spot where I stop recording.
Here.
Record 1, 2, 3.
Yep, so there it
well,
goes.
okay, so that's running.
So
So if I press
we're going to go back into
record
SuperCollider
once, it
and
should be
press
recording,
Command
blah, blah,
period to stop it. We'll have to make a stop button obviously later, and we'll do that. Okay, so that works. So just a quick review. Then maybe I'll stop this tutorial and pick up the play later, even though it's the same. No, maybe I'll just carry on. It'll just be an extra long one. So basically, I press the mouse once, record starts. I press it again, it stops. All right. So why don't we? Let me see. How can I do this so that it's simple enough? So what we need to do now is, well, you know what? Sorry, I keep changing my mind, but yeah, I think it turns out that we have to make some adjustments in processing that might take a little bit more time. So why don't I end this tutorial now, and then part 6, we'll pick up how we can sort of create another toggle for starting play and stopping play. Okay, so that was kind of a long one, but hopefully some of those things are pretty clear.